I'm Nitish, and I'm thrilled to be presenting on the topic crafting adaptive user experiences, a multidisciplinary approach to responsive web components. With a background in web development and user experience design, I have dedicated my career to creating seamless and dynamic online interactions that cater to a wide range of devices and user needs. Today, we'll deep dive into the principles, practices, and technologies that can help us achieve truly responsive and user-centric web components. In our multi-device world, creating web components that automatically adjust to diverse contexts like mobile, desktop, and embedded systems is crucial for delivering seamless user experiences. This presentation explores a multidisciplinary approach to designing reusable UI modules that dynamically adapt. We'll leverage modern web technologies such as semantic HTML5, CSS3, and JavaScript to optimize visual hierarchy, information density, and layout capabilities across devices and networks. Let's consider why responsiveness is so vital. Users now access websites on a plethora of devices, from smartphones and tablets to desktops and smart TVs. Each device offers a different experiences based on screen size, resolution, and user interaction methods. A responsive design ensures that no matter what device a user is on, they have a smooth and engaging experience. This isn't just about scaling images or changing font sizes. It's about rethinking how content is delivered and interacted with. We'll also discuss the evolution of web design. Back in the early days of the web, designers created separate versions of websites for different devices. However, this approach quickly became unsustainable as the number of devices types grows. Responsive design emerged as a solution, allowing a single code base to adapt to various screen sizes and orientations. This evolution highlights the importance of adaptability in web development. Responsive design principles are foundational to our approach. By focusing on visual hierarchy and optimizing information density, we can ensure that our design remain clear and effective across different devices. Layout APIs like Flexbox and CSS Grid enable us to create flexible and accept adaptable layouts. Declarative responsive designs use media queries to apply different styles based on characteristics like viewport width, which helps keep content accessible and optimizing it for each context. Let's delve into visual hierarchy. This principle involves structuring content so that the most important elements are prioritized visually. Techniques like using larger fonts for headlines, contrasting colors, and strategic white space can guide the user's eye to key information first. Flexbox and CSS Grid come into play by allowing us to create complex responsive layouts. These tools provide powerful methods for distributing space and aligning items, making our designs adaptable with sacrificing aesthetics or functionality. Another aspect is the use of media queries. Media queries enable us to apply different CSS rules based on device characterizations such as width, height, orientation, and resolution. This allows us to create a single style sheet that adapts to various devices, rather than having to write separate style sheets for each one. This not only simplifies maintenance but also ensures a consistent look and feel across all platforms. We can also discuss the importance of fluid grids. Unlike fixed grids that use set pixel values, fluid grids use relative units like percentages, which scale seamlessly with different screen sizes. The approach allows our layouts to adjust smoothly, providing a more cohesive and user-friendly experience. Maintaining power and accessibility standards is critical. Studies have shown that responsive modules load 37% faster than their non-responsive counterparts, underscoring the importance of performance optimization. We'll discuss how to balance visual adjustments with usability, ensuring interfaces conform to accessibility standards like WCAG across various contexts. Performance is key to user retention. Slow loading pages can frustrate users and leads to higher bounce rates. Techniques such as image optimization, lazy loading, and minifying CSS and JavaScript can significantly enhance load times. Using modern image formats like WebP can reduce file sizes without compromising quality. Lazy loading defers the loading of non-critical resources until they are needed, improving initial load times. Accessibility ensures that our designs are usable by everyone, including people with disabilities. This involves using semantic HTML elements, which provide meaningful context to screen readers and ensuring sufficient color contrast for users with visual impairments. Implementing ARIA attributes can also help make dynamic content more accessible. For example, ensuring that all interactive elements like buttons and links are keyboard navigable is essential for users who rely on assistive technologies. To illustrate, consider a case study where a website redesign incorporated these principles. By optimizing images, reducing the number of HTTP requests, and improving code efficiency, the website's load time is reduced by 50%. Additionally, implementing ARIA roles and improving color contrast resulted in a 30% increase in accessibility compliance, making the site more inclusive for all users. Mobile accounted for 67% of global online traffic by 2021, highlighting the importance of responsive design. Nearly 60% of developer teams now prioritize responsive design to boost revenue and retention. A mobile-first approach considers constraints like smaller viewports, creating lean, performant experiences that scale up seamlessly. Designing with a mobile-first mindset means starting with the smallest screens and progressively enhancing the experience for larger screens. This approach ensures that the essential content and functionality are accessible on all devices. It encourages simplicity and efficiency, which are critical for performance on mobile networks. For instance, mobile-first design might prioritize essential navigation and content upfront, ensuring that users on slower connections can access the most important information quickly. A mobile-first approach often leads to cleaner, more focused designs by addressing the limitations of mobile devices first, such as smaller screen sizes and touch-based navigation. We create a strong foundation that can be expanded for larger screens. The result is a more cohesive and user-friendly experiences across all devices. We can also consider real-world application. For example, a popular e-commerce site implemented a mobile-first redesign, resulting in a 20% increase in mobile conversion rates. By focusing on mobile usability, they were able to create a streamlined shopping experience that created the users on the go, ultimately boosting overall sales. Achieving responsive, universal web experiences requires architectural shifts from client-side scripting to universal delivery, augmented by progressively improved server-rendered structures. These shifts align with modern web developments, increasing use of reusable components delivered efficiently across contexts. Modern web development trends such as server-side rendering and static site generation are becoming more popular. SSR generates HTML on the server for each request, ensuring faster load times and better search engine optimization. SSG, on the other hand, generates HTML at build time, which can be served quickly by a CDN. Both approaches help in delivering content efficiently, reducing the reliance on client-side JavaScript, which can be a performance bottleneck. Using frameworks like React, Vue, or Angular with tools like Next.js or Next.js can facilitate these architectural shifts. These frameworks allow us to build reusable components that can be rendered on the server or at build time, improving both performance and maintainability. By adopting these modern practices, we ensure that our applications are scalable, fast, and reliable. To put this into perspective, consider a large news website that adopted server-side rendering. By delivering pre-rendered pages from the server, they significantly improve their load times and search engine rankings. This architectural shift not only enhanced user experience but also increased organic traffic by 25%. Incorporating usability research and usage analytics is key to elevating fragmented experiences into cohesive ones adapted for each form factor. A user centered process identifies pain points and crafts unified interfaces compatible with the full range of contexts users encounter. User-centered design focuses on the needs, of preferences, and limitations of end users at every stage of the design process. This involves conducting user research, such as interviews, surveys, and usability testing, to gather insights into user behavior and preferences. By understanding how users interact with our designs, we can create more intuitive and satisfying experiences. Usage analytics also play a crucial role in UCD. Tools like Google Analytics, Hotjar, and Crazy Egg provide valuable data on user behavior, such as where users click, how they navigate through a site, where they drop off. This data helps identify area of improvement and validate design decisions. For example, if analytics show that users are frequently abandoning a form halfway through, it might indicate a need to simplify the form or provide better guidance. A case study on a travel booking site illustrates the impact of user-centered design. By conducting user research, they discovered that users found the booking process confusing and cumbersome. Through iterative testing and redesign, they simplified the process, resulting in a 40% increase in completed bookings and significantly higher user satisfaction scores. While being flexible, consistent guidelines balance stability. We'll cover emerging best practices for planning, developing, and maintaining responsive components and systems. These actionable insights aid business in creating resilient dynamic web experiences that provide value long term. The best practice is to adopt a design system. A design system is a collection of reusable components guided by clear standards that can be assembled to build any number of applications. Design systems promote consistency and efficiency, making it easier to maintain and scale your design across different projects. Example of popular design system includes Google's Material Design, IBM's Carbon Design System. Another best practice is to ensure cross-browser compatibility. Despite the prevalence of modern browsers, users may still access your site using older versions or different browsers. Using tools like Browser Stack or cross-browser testing, you can test your designs across a wide range of browsers and devices to ensure a consistent experience. Performance optimization should be an ongoing effort. Regularly audit your site with tools like Lighthouse or Web Page Test to identify performance bottlenecks and opportunities for improvement. Implementing techniques such as code splitting, where only the necessary code is loaded or given for a given page, can also enhance performance. A real-world example of best practice in action is a major financial service company that implemented a design system. By standardizing their component and guidelines, they were able to reduce development time by 30% and maintain a consistent user experience across all their various platforms and services. This approach, combining recent web specification advances with user-centered design principles, unlocks transformative potential for crafting strong online presence. Embracing it empowers us to create adaptive, accessible experiences that gracefully span the expanding ecosystem of internet-connected devices. By staying up to date with the latest web technologies and continuously refining our design and development process, we can create websites that not only meet current user expectations but also anticipate future trends. For example, the rise of progressive web apps offers new opportunities for delivering app-like experiences directly through the web, combining the best of both web and native app worlds. Progressive web apps provide features such as offline access, push notifications, and fast load times, enhancing user engagement and retention. By adopting PWA standards, we can create more resilient and versatile web applications that work seamlessly across all devices and network conditions. Consider a retailer that adopted PWA. By offering offline functionality and push notifications, they were able to keep users engaged even without an internet connection. This led to a 50% increase in user retention and higher overall customer satisfaction. In conclusion, delivering robust, highly adaptable user experiences requires a multidisciplinary approach, leveraging modern web standards, performance optimization, user centered and accessible design, and flexible future proof architectures. Thank you for joining me today, and I hope this presentation has provided you with valuable insights into creating responsive web components. The key to successful responsive design lies in understanding your users, embracing new technologies, and continuously iterating on your designs. By following the principles and best practices, you can create web experiences that are not only visually appealing, but also highly functional and accessible to all users. Thank you for your attention, and I look forward to any questions or discussions you may have.